Hello. In this video I will be demonstrating RoCE in combination with Comware 7 top-of-rack switches. This video demonstration is based on a test document that can be downloaded from the link that is shown in the video. RoCE is short for RDMA over Converged Ethernet. RDMA is short for Remote Direct Memory Access. RoCE is a network protocol that allows RDMA over a lossless Ethernet network. RoCE is a link layer protocol which allows communication between any two hosts in the same Ethernet broadcast domain or based on IP addressing. RDMA introduces the concept of zero copy data placement, which allows specially designed RDMA network interface cards on both ends of a connection link to transfer data directly from the user memory of the source server to the user memory of the destination server, bypassing the operating system kernel as shown in the diagram. Because the RDMA data transfer is performed by the DMA engine on the NIC, the CPU is not used for memory movement, freeing it to perform other tasks, such as hosting more virtual workloads. RDMA reduces latency and improves throughput by bypassing the host TCP/IP stack. At this moment there are two versions of RoCE. Version 1 allows direct memory access through protocols like InfiniBand, whilst RoCE version 2 uses UDP for data communication and is therefore routable. In order to have the RoCE functionality, you must have a NIC that supports RoCE functionality. The Emulex based NICs from HP Enterprise, for example. With rack mount service, an HPE 556 FLR or 557 SFP Plus adapter can be used, and they use the same chipset engine as the Emulex XC100 series. The HPE 650 FLB can perform 20 gig Ethernet transfer rate when connected to a 20 gig capable blade interconnect. So let's show the configuration. The setup is according to the diagram that is shown here. There are two DL380 servers containing the 556 FLB NIC connected to a pair of HPE 6125 XLGs that are configured in IRF. One thing to mention is that RoCE is not supported in combination with NIC teaming. Therefore, we will have a single link performing the file transfer. We have configured the servers to use 802.1q tagging. Let me show you how this is set up on the servers. So we go to the network sharing center, change the adapter settings, check one of the network card properties, go to configure NIC, advanced, VLAN identifier. You can see here that we've set the VLAN value to 10. Of course, we also have to configure 802.1q on the switches. This means creating the VLANs on the switch, changing the personality of the ports to trunk ports, and allowing the tag traffic for the given VLANs. So the first step of the configuration is to change the personality of the network adapters to support RoCE. We can do this in the one command management utility that is provided with the network interface cards. So we can see here that we have a network adapter in the server. So what we can do here is we can go to the adapter, go to adapter configuration, and then change the personality to NIC and RoCE. We apply the settings. So once we've applied the settings, you can see here that a reboot is required. So that's what we're going to do. So after reboot, this is the configuration of the network adapters on the servers, shown with one command. Notice that the network adapters have been configured for RoCE, and we're using RoCE version 2. So this allows IP-based SMB transfers. So also we can check the Nic parameters to see if RoCE is working. So we take one of the network adapters, go to the configure, advanced, and then we scroll down to the protocol offloads, and what we can see network direct has been enabled, which is the same as RoCE. Another thing that we have to check is the MTU size. So we have to make sure that the MTU size is set to a higher value than the default size. So in this situation we set the size to 4K. It is also necessary to prioritize the RoCE traffic versus other types of Ethernet traffic. Converged Ethernet requires DCB support, and DCB provides priority flow control PFC for point-to-point connections. So for this we have to install the DCB functionality on the servers. So this is done by selecting the adding roles and features. So we click next and we go to the features. DCB resides under the features functionality. So we can see here that we already installed DCB, the DCB functionality, but if it's not installed you have to select this one and then install it. Once the data center bridging functionality is enabled, we can configure the Qos parameters, the Qos settings in a one command utility. So what we can do is we go to port and then we can go to DCB here. You can see that the DCBX state is set to enabled, so it's already running. But we can configure, so if you want to make some changes, we can configure this here. PFC is also enabled here. And the P value is set to 5, so all traffic will be marked with the P value of 5. So let's enable it, and you can see here that it's all enabled and synced. And then finally we have to configure the switches. So this has already been done, but let me show you the configuration steps. So first we have to create a couple of ACLs that we need to assign later on to the traffic classifiers to identify the RoCE traffic. So let me show you the ACLs. So we've got two ACLs here, 3001, 3002, and you can see here the TCP destination and source port 445. And then the next step is to create a classifier, a traffic classifier, a traffic behavior, and a Qos policy that identifies the RoCE traffic. So let me show you the traffic classifiers. So there's one here, and what we've done with the classifier is that we have assigned the ACLs 3001 and 3002 to this classifier. And then let me show you the traffic behaviors. So there's one traffic behavior here, and this one remarks the traffic with a .1 p-value of 5. And then let me show you the Qos policy. So we've got one Qos policy here called DCBX, and what I'm doing here is I've assigned the DCBX classifier and the DCBX behavior to that policy, and that behavior is remarking the traffic. And then finally we have to configure the switches. This has already been done, but let me show you the configuration steps. First, we create two ACLs that we need later on to identify the RoCE traffic. So let me just show you the ACLs. So there are two ACLs here, 3001 and 3002, and you can see that we're classifying the SMB traffic, TCP port 445 for the source and destination. And then the next step is to create a traffic classifier. So let me show you the traffic classifiers that have been created. Should be just one. So there's one here, and in that classifier you see the ACLs. So these are assigned to the classifier. And let's do the same thing for the behavior, because that's the next step, is to create a traffic behavior. User defined. And I've got one behavior here, and this behavior is remarking the traffic with the p-value of 5. And then once you created the classifier and the behavior, you can assign it to the Qos policy. So let me show you the Qos policies. And there's also one, which is the DCBX policy. And you can see that the classifier and the behavior have been assigned to the Qos policy. And then the final step is to configure the interfaces. So let me show you the configuration of one of the ports, and the configuration of all the other ports are identical. So I'll just go to one of the ports here. Just go 10.10.47 and do it, display this. Very handy, useful command. So what we see here is you can see that the link type has been set to trunk, and we are allowing VLAN 10. Well, we also allow VLAN 100, but for this configuration VLAN 10 is relevant. PFC is enabled, and we have set the PFC priority for packets with the 802.1 p-value to no drop with a p-value of 5. We've also enabled the lldp tlv for DCBX so that the service can exchange the information with the switches, and we are trusting incoming 802.1 p traffic. We've set the MTU size to 5000 to allow larger packets coming from the service. And then finally we have assigned the Qos policy for DCBX to the interfaces on outbound traffic, so that any traffic that matches the TCP source and destination, port 445, will be marked. So just to make it easy for you, I've put the command sequences in the comments below, so you can use those. So once this is configured, you should have RoCE running with PFC prioritization on your network. This concludes the RoCE demonstration. Thanks for watching. Please like and subscribe and/or leave a comment below.